All right, so this is probably the last one I'm doing today. Maybe not. Let's see if I get another burst of wind. 31 is a repeat. We covered that, problem 18. So if you want some practice with that skill, go to number 18. All right, so this is just language. Do you know what to do to the quantity 1 over 125? Well, the first thing I would do is I would do the minus sign, which is reciprocation. So that just gives me 125 if I use it. And then that is to the 1/3. And you need to know that that 1/3 means the cube root of 125. And that's 5. I'll do reciprocation last, but I would perform that operation, that 3, which is the cube root of 8. And that still has to be to the -2. That's 2 to the -2. And at this stage, I hope you just write 1/4 and know why. 3/4 to the -2. I think I'd reciprocate it. 4/3 squared. And that's equal to 16/9. I'll reciprocate last, but I think I'll take the square root of 16, which is 4. And 4 to the -3 is 1 over 64. I'll reciprocate first. So that's 16 to the 3/4. Hopefully you're getting the swing of things there. So that's the 4th root of 16. And then I got to cube it, which is 2 to the 3, which is 8. Yep, reciprocate first. All right, so there's a little practice, and you've been doing pretty well with those. So we'll move on. Didn't do too well on this one, the last test, which tells me that probably didn't look at the videos. Only one person was able to do this. Quite frankly, I think you do this at a much earlier grade level. So Pythagorean theorem. All right, that square area, these are all drawn in standard position, first, second, third, fourth quadrant. It's going to head us to, it's going to head us to trigonometry. Brain's getting tired here. So that's 25 units of area, 11 squared is 121. The smaller ones add up to the bigger one. So I'm going to take this one away from the bigger one. And that's going to get me 96 square units, which is 4 times 24. Oh, there's another 4 in there. So that's 4 times 4 times 6. Wow. So that's actually 16 times 6. And if I'm going to take that square root, would be nice if we called it 4 root 6. But I'll take the square root of 6, 96 at this stage. That's moving in the right direction. All right, so we've got 9 units of area here. We've got 25 units of area here. And the diagonal is always positive, like the hand of the clock. So Z is going to be 25 plus 9. That's going to be 34 big units of area. So what is that? That is the square root of 34. Okay. So what do we have over here? We've got 16 units. We've got 49 units. So what is that going to be? That's going to be 49 minus 16, which is 33. So what is this x distance? The square root of 33. Ah, terrible mistake on my part. That should have been -4. The brain is definitely getting tired, but it doesn't change anything. It's still 16. All right, so -8. This is going to be 64 units. 10 is going to be 100. Oh, I recognize this one. This is the 3, 4, 5 doubled. Yeah, and so therefore that's 36 units. Got to be careful with this one because that's in the second quadrant. So that's -6. Yeah, you haven't done much work with the negatives yet, so it stands to reason you might have made a mistake there. Yeah, I definitely have to have this be the last video because I'm getting too tired. So that's 91, that's 49, 91 minus 40 is 51 minus 9 is 42. So this is 42, the square root of 42, 6 times 7, no perfect squares there, so square root of 42. All right, now, how do we do distance? The same way we did these problems. If you connect a point to another point, you have rise over run. And if you connect the dots, You gotta know the triangle, just like the ones you've been looking at here. The distance formula, you don't really worry about pluses and minuses. It's really all about change. 3 to 7 is 4 units. 5 to 11 is 6, so that's 16 to 36. My distance is going to be the square root of 52. Okay. Now, let's actually plot 3, 5. Let's call that 3, let's call that 5. Boom. Let's plot 7, 11. 7 is over here, up 4 units, right? 11 is up 6. So 7, 11 is here. All right, so how do you get from 3 to 7? Over 4. How do you get from 5 to 11? Up 6. And so what is that distance? 16, 36, 52, square root of 52. All right, let's do negative 2, 9, 2, 4, 5. And then we'll take shortcut on the last one. Negative 2, 9. Coordinate system, let's call that negative 2. Let's call 9 up here. All right, we're moving to 4, 5. Over 4, up 5, let's call that 4, 5. Okay, so negative 2, 9. Negative 2 goes over to 4. That's 6 units of change. Negative 2, 9, right? Okay, so it was 9 was the y value, and I'm going to 5. That's 4 units of change. This looks like the same problems I did before. Maybe I already did it twice. There's 6. 9 to 5 is 4, so that's 36 and 16 again. Of course, I went down 4, but it doesn't matter. It's 4 units of change. By squaring it, get a positive. So that's 16 and 36. That's 52 again. So that distance square root of 52. Must be some Freudian stuff going here. So how far is it from 1 to 5? 4 units. You're going to square it. How far from 2 to 7? That's 5 units. You're going to square it. You're going to add those up and take the square root. And that's the distance between those points. But we'll do it out. 1, 2 to 5, 7. 1 to 5. 1 to 5. That's 4 units of change. 2 to 7. That's 5 units of change. This might be a better way to do it. So what is this square area here? 5 squared is 25. What's this square area here? 16. See that here? And so that's 41 units of change. And so what's my hypotenuse here across from that 90-degree? Square root of 41. Okay, so too tired to keep going. Negative 4 to 5 is 9, so I got 81 units of change. 7 to 11 is 4, that's 16. I add that up and I take the square root, and I got the distance between 2 points, square root of 97. All right, gonna do some real quick solving of logs. You're pausing the video. I'm just gonna do 4. You can see all 4. All right, so 4x equals 2 to the 5th. The inverse of log base 2 is bringing the base over, because this is an exponent, and exponents go on top of bases. So 4x equals 32. Looks like x is 8. Got to subtract 7. It's 4. Going to divide by 2. That's 2. The inverse of log base 3 is 3 to the. That's 9. And I'm going to add 6. That's 15. You put 15 in here. Go back to the original problem. Should work. Yep, I'll do more videos tomorrow morning. So 2x minus 5 over 6 is the quantity that comes from 3 to the negative 1. Oh, I guess I got to do it over here. So 2x minus 5, I'm going to multiply 1/3 by 6. 3 to the negative 1 is 1/3. And division by 6 becomes multiplication. So that gives me 2x minus 5 equals 2. That's 7/2. So 7/2, what happens to the 2's? They cancel. 2 minus 5 is 2. What is 2/6? That's 1/3. And what's the exponent you put on top of the 3 to get 1/3? Negative 1. Okay, last problem of the day for me. Definitely. We'll subtract 7. Gives us a 1. We're going to multiply by 1/3. Oh, that's 1/3. Ah, this was a dyslexic moment for me. Because I wanted 4 to the 364. Yeah, I forget to change this. Yeah, I don't think I do this too well. Let's just get an exact answer. All right, we're involved here, so I gotta do 4 to the 1/3. Okay, I'm gonna erase this now. Right, and I'm gonna write this as equal to 4 to the 1/3. And we're gonna look at how to get a nice answer here. Well, first off, I think you should rewrite that as the cube root of 4. Okay, because all you're gonna do then is multiply it by 3. And then add 5, and you're done. So it wasn't that you couldn't do it, it's just that you're used to integer answers and, you know, everything isn't an integer. So it's good that you at least see that. It was all about inverse operations, and you might have to replay those. Try them in class. May 15th, remember that date. That's when I want to know that you got this right. All right, and we'll be doubling up on these questions soon.